Binomial theorem. We're going to start a new section. This is kind of standalone. You might see notation appear again at later times, but overall this is a standalone set of questions. So how easy is it to expand these expressions? I would expect you to be able to expand some brackets easily, but I think you'd find that pretty hard. And this exceptionally difficult, but by the end of this section, that's what you should be able to do. So you're going to learn techniques to cope with such problems, but let's start with more manageable problems first. So I would expect you to know how to expand x plus y squared and even to the 4. So x plus y squared, you should know it's a bracket times the bracket, and you should know how to expand brackets. Whichever way you do it, you end up with x squared plus 2xy plus y squared. I would actually hope that you could go from that bracket to that instantly, but if you need to, there's a 2. Using that answer from x plus y squared, we could write x plus y to the 4 as x plus y squared squared. So then we could expand x plus y squared to the answer we had already. And to make it easier, and you'll see this again in complex numbers, that I multiply complicated brackets using a grid. It is not easy, well, it's making it easier, but it's not changing the level of what you're doing. So x squared times x squared is x to the 4. And if you times this by x squared, you get x cubed there. And if x squared y squared, we have 2xy times x squared is 2x cubed y. 2xy times 2xy gives you 4x squared y squared. 2xy times y squared gives you y cubed. And then x squared y squared times by y squared, you get 2xy cubed, and times by y squared and y squared, you get y to the 4. Why is it really useful to do this? Because you can see diagonally, I've used colours to emphasise there. You can collect terms together really easily then, okay? So let's go through what we've got. We have x to the 4. It's the only one. I'm using colour so you can see this. So it's the only one that's got x to the power of 4. Whereas the purple ones, you can see they have 2x cubed y, and 2x cubed y gives you 4x cubed y. Then we've got x squared y squared, and 4 of them, and 1 more of them means you've got 6 of them. 2xy cubed gives you 4xy cubed, and lastly you've got y to the 4. So it means that you have managed to expand 4 brackets if you wrote it as x plus y 4 times, okay, and got your answer. We don't have to do all of that all the time. You could do it that way and try x plus y to the 6, so you would have the x plus y to the 4 with me, multiply that by another x plus y squared, and use the multiplication grid and find your answer. However, this topic is intended for you to learn new methods to expand brackets far more quickly, and also find particular coefficients with these at a later stage. Firstly, we need to be introduced to some new notation and processes. So the first thing we need to know is this exclamation mark actually means factorial. And factorials are represented with the exclamation, so this would read n factorial. It is the product of integers decreasing down to 1. So that means you've got n, n minus 1, n minus 2, and so forth. And in fact, when I say product of integers, it's actually of natural numbers. So n factorial starts with n, then it goes down n minus 1, n minus 2. So you always start with a number and reduce down to 1. Just to remind you what a natural number is. A natural number is like 1, 2, 3, 4. It does not include 0, it does not include fractions, and it does not include negatives. So you might say it's the product of integers, but it's actually the product of positive integers in that case. Right, so let's try it. So if it starts with a number and reduces down, 3 factorial will be 3 times 2 times 1. And you can find the answer. 4 factorial will be 4 times 3 times 2 times 1. And then 5 factorial will be 5 times 4 times 3 times 2 times 1. Okay? So what would 6 factorial be? Think about it. I hope you've got 6 times 5 times 4 times 3 times 2 times 1. Do you remember what the 5 factorial was? It was 120, and you get your answer. Okay? As n increases, the factorial increases rapidly. You could almost say exponential. Right, obviously it's getting bigger and bigger. Look at this calculator below and where the setup button is here. And below the setup button, you'll find the x to the minus 1 button here. If you look carefully, what you'll find is that just above it in mustard is the factorial button. So we're going to learn how to use that as well. So if you press shift or second function, and the x to the minus 1 might be a different button on different calculators. You can use the factorial on the calculator. Be aware it may be in a different place, but you know what you're looking for now. So let's just check you can use your calculator. So if you have 3 factorial, I'm expecting you to press 3, shift or second function, and then the x to the minus 1, or whatever your button is, and you should get out 6 because 3 times 2 times 1. For factorial, check 4 shift, 5 shift, okay, so, and 6 factorial. If your calculator isn't working right at this point, stop the video and then have a look and try and figure out what's wrong. Okay, let's move on. So now use the calculator and find days. I'm not going to read the number, I'll just reveal it. So 10 shift factorial. Is that what you got? 13 factorial. Did you get that? 15 factorial. What you get? We'll come back to that. Okay. Right, factorials. So as they go, n factorials, n times n minus 1 times n minus 2 and so forth all the way down to 1. 3 factorial is 3 times 2 times 1, which we talked about. That means 4 factorial is 4 times 3 times 2 times 1. Do you notice the colour? The colour's there because 3 times 2 times 1 was 3 factorial. So you could also write that as 4 times 3 factorial. You can still calculate it, no problem, but this is the key part here. Okay, so if you know 4 now is 4 times 3 times 2 times 1. What's 5 factorial? 5 times 4 times 3 times 2 times 1. And look, I've got that all in purple because can you see it's 5 times 4 factorial then? So you could then just leave it like that if you were asked to rearrange it in any way, but obviously we know that's 5 times 24 and we get 120. Okay. So if it's 4 factorial, it's 4 times 3 factorial, 5 factorial is 5 times 4 factorial, so we're going to try and find a rule. So if we have n factorial, it's n times n minus 1 times n minus 2. So what would you do if it was n minus 1 factorial? What would the first number be? Not number, expression. Okay, so, or term. So n take 1. What's the one below it? Times n take 2 times n take 3. So you can do it for other forms, not just n. And what about n plus 1? So you start with n plus 1, and what's less than that? N, and n minus 1, n minus 2. So you might see variations. Okay. Right, so let's just prove this new rule we've got. So n factorial means n times n minus 1 times n minus 2, and so forth. And n minus 1 factorial therefore means n minus 1 times n minus 2, so forth. Can you see anything cancelling down? So can you see that the n minus 1s can cancel? The n minus 2s, this should work. Come on you, cheeky chops. Oh, for goodness. This worked no problem before. Oh man. They should all cancel out nicely. There you go. I'm not going to stop it because I've tried this a few times. I'm just not going to waste your time anymore. So what happens is n factorial over n minus 1 factorial, all the top cancels except for n. So it doesn't go to 0 here. It means it's n over 1, so it goes to n. Cross multiply, you end up with n factorial is the same as n times n minus 1 factorial, which we were talking about. So 4 factorial is 4 times 3 factorial, 5 factorial is 5 times 4 factorial, and so forth. So that's a nice rule for you to know. So let's go through this. So n factorial could be written as n factorial is n times n minus 1 factorial, and n plus 1 could be written as even n plus 1 factorial is n plus 1 times n factorial, and so on. Okay. Right, so let's see if you know these. So let's start with the rule. You know that. Okay, so let's go positive first. So you would start with the term n plus 1 and then take 1 off it. So what would you do for this one? It would be n plus a. What's 1 less than that? And let's go back the way you start with n minus 1. What's less than that? Okay, so you could do it for a whole variety of things. Right, so 4, just remind yourselves, 4 times 3 factorial, 5 times 4 factorial. How'd you do 16 then? 16 times 15 factorial. Okay. Right, so 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I've just put brackets there to emphasize that's 9 times 8 factorial. So there's 2 questions, but we're just doing them right here and now. So how are you going to write 8 factorial? Is that what you came up with? How would you do 12 factorial? Is that what you came up with? Okay. Right, let's go to 15. Get your calculator. What's 15 factorial? When you get to 15 factorial, you get scientific notation because it's so huge. Okay, so let's count 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. So if it's times 10 to the 12, then we're moving at 9 plus 3 more. So that's the actual number that's 15 factorial. Okay. Now, if I want to get the one up from that, which will be multiplying it by 16 then I'm going to do it by hand first. Now, you can do it by hand and stop this if you want. I'm going to do it just now. So if I multiply by 16, I'll multiply it all by 6 first. So 6 zeros, 6 zeros, 6 zeros, 6 eights are 48. Remember, carry the 4 and so forth. So we're going to do this. So that's what I get from my first part. How do you times by 10? Remember, it's not timesing by 1. If you times by 1, it's what you've got, but it actually means times by 10. So you effectively put the 0 down and then multiply. So it's the same number with the extra 0. Collect together 0, 0, 0, 8, 8, 8, 9, 8, 7, and so forth. Okay, so that is when I multiply by hand. So if you had 15 factorial to start with and you times it by 16, it's also the same as 16 times 15 factorial if I just switch it around. And going by the skill you have before, that means that this must be the same as 16 factorial. Well, let's check it in your calculator. So what we're going to see is, are they exactly equal? So your calculator will read that. Check it out. I've just expanded it. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places again. So I've moved it 9 plus 4 more. So that's what it is in full. So this is the calculator answer. And this is my answer by hand. And do they look exactly the same? Well, you can see I've highlighted. Almost all of it's the same except for these digits here. Now, that's actually a difference of 2000s, which is a big difference, but you might not notice because it's a huge number. So these may be very large numbers with only a small difference, but they're not the same at all. And it's just to illustrate that if you do use the calculator, there's limitations on it. And we will be using techniques to try and eliminate that problem. 0 factorial is one that's special because I said earlier on about natural numbers, and if you recall, natural numbers do not include 0. So what about n factorial in this situation here? Well, n factorial goes all the way down to 1. So they must be able to find 1 factorial. So what would 1 factorial be? It would be 1 times 1 less than 1, which means 0 factorial appears by magic. So we all know that 1 is made up of 1 times 1. So this means that 0 factorial, by convention, we give it the value of 1. So it's a special case. Think of it like indices to the power of 0 is 1 as well. Okay, so it's a special condition. Right, what have you got to do now? I've set you up with a DAT quiz code. You don't need to worry about clicking this because you'll find I've got a link for